Okay, so good evening to you. We are looking at the issues pertaining to the matters of cost of debt, KD, matters of cost of debt. And I indicated that in the work formula, we tend to have KD as a basis of also computing it and using it and also helping with the computation of work. And I indicated that the work percentage is having a negative relationship with cash flows. The work percentage, which is also the discount factor, is having negative relationship with cash flows. What is the relationship? An increase in work will lead to a fall in the discount, or it will lead to a fall in the discounted cash flows. Maybe that statement is not clear to you. In dealing with issues of, for example, let me just create an example over here. If the work happens to be, let's say, 10%, and you are using it to discount cash flows, compare with another work which its percentage is 15%. We are saying that if you are using the higher work, which is the cost in discounting cash flows, the higher work will give you a smaller discounted cash flow. So we can use cash flows such as, let's say, year one. Let's say we have a cash flow which is 300. This is a cash inflow because it's positive. Then we can have year two, a cash inflow of, let's say, 450. Then you can have year three, a cash inflow of, let's say, 580. These are cash flows. And if we are to discount these cash flows with 10% discount factor, we will actually get 0.909. How am I getting the 0.909? I've indicated that discount factors are calculated as 1 over 1 plus R, right? Way of computing a discount factor. So it is 1 over 1 plus R, 1 plus R, all to the power what? N, to the power N. This is a way of computing what? Discount factor. So if I slot in here R to be 10%, because if the discount factor is 10, then I can slot here by making it 10%, not just 10, but 10%. Then thereafter, what do? The denominator is the next bit to look at. I'll say 1 plus 10% means 0.10, bracket close, to the power what? 1. Doing this will give me what value? Will give me 0.909. But you recall that I gave some shortcuts in the case of determining discount factors, that if you slot in and you get the first answer, what you have to do is that here you have to add the figure in the brackets, and that is what you'll be using to divide all the numbers. So over here, 1 plus 0.10 will give you 1.1. And when you divide that 1.1 by 0.909, you get the next discount factor straight away. So if you can see on the screen, this is the year one discount factor. Year one discount factor. If I want to get year two discount factor, what some students will do is that they'll use the calculator, move backwards, shift, then they move backward, and then this one here, which is the number of times, that is the n, which is the one here, they will now change this one to, let's say, 2. But I'm saying that that technique is okay, but on the day of exam, it is not the fastest technique ever. So if I want to look at the fastest technique, what I have to do is that I need to input this on the calculator, press an equal to sign, get my 0.909. But if I want to get the discount factor for year 2, year 3, year 4, year 5, in a very smart perspective, what I have to do is that in getting the discount factor for year 2, it is going to be the discount factor of year 1, which I got it to be 0.909, right? I'll now divide this 0.909 by the 1.10 quickly. Then I'll automatically get 0.826. If I want to get the discount factor of year 3, let's say year 3, I want the discount factor of year 3. Year 2, I got 0.826. So what I'll do is that I'll divide this by 1.10 again. Then I get what answer? 0.751. Then I move on. If I want the discount factor for year 4, that's 0.751 that I got. I will divide it by 1.10. Then what do I get? I get 0.683. I move on. If I want to get the discount factor for year 5, what do? The last answer I got was 0.683. I will divide it by 1.10. Now the question here is that Where are we getting this 1.10, 1.10 we are talking about? The 1.10 here, the other 1.10 you can see here, right? So it's just about struggling to get the first answer. If you get the first answer, you divide it by what is in the bracket. This 1.10 came by the addition of 1 plus 0.10. And that gave us 1.10 or 1.1. So in effect, after getting the first answer, you need to just struggle to get the first answer. If you get the first answer, you divide it by the addition of what is in the bracket. So here I got the first answer to be 0.909. If I want the second answer for year 2, I'll divide that 0.909 by 1.1. Then I got 0.826. I wanted the discount factor for year 3. I divided the last answer, which was 0.826 by 1.1 again. I got 0.751. 0.751 divided by 1.1. I'll get for year 4. Divided by 1.10. I'll get for year 5. On and on and on and on and on. That way. So that is an easy way of computing and getting these discount factors. But over here, I need the discount factor of year 1 to year 3 only. So here is 0.826. And the next bit will give me 0.751. So what do? I'm going to multiply these cash flows. I want to show you. So we have these bits here to be the cash flows. They have the next bit to be discount factor. Then we have the next bit to be discounted cash flow. We have discounted cash flow. So what do? I'm multiplying 300 here by 0.909. And what answer am I getting? Something like 272. But let me try that at my end. Ensure that I'm in good shape. So 300 times 0.909, that gives us 272.7. Then I move on to the next bit, 450 times 0.826. That will give us 371.7. Then the next bit, 580 times 0.751. And that will give us 435.58. So thereafter, when I add all the discounted cash flows, so the discounted cash flow in total, these are all cash flows, but they have been discounted to the same year, that is year 0. Any figure which is discounted has been discounted to year 0. And that if any figure is in the present value, that figure is already in year 0. That means that it has already been discounted. So by adding them up, 272.7 plus 371.7 plus 435.58, I am getting 1079.98. So that's the total. Now, what are we trying to do? We are trying to prove whether an increase in WACC will have a negative impact on cash flows. So we assumed a WACC percentage of 10%, and we have discounted using the 10%, and you have got a total discounted cash flow to be 1079.98. This time around, we are going to use 15% as a discount factor to discount these cash flows. Then we will see the impact. So still year 1, we are having 300 here as a cash inflow. Year 2, we are having what value? We are having 450 here as a cash inflow. Year 3, we are having what value? We are having 580 here. So what do we need? So this is the cash flow. Then the next bit is the discount factor. But here the discount factor of what? We are looking at the discount factor of 15%. And what is the discount factor of 15% for year 1? It is easy. So say the discount factor is equal to 1 divided by, they come down a little bit. You say 1 plus 0.15, 15%, 0.15 to the power what? To the power 1 for the first year. So the bit is over here is to how do I get that of year 1? If I get that of year 1, I'll divide everything by what is in the bracket. And what is the bracket? 1 plus 0.15 will give us 1.15. The only problem here is how do I get the answer for the first year? And the answer for the first year is going to give us what? That is 1 over 1 plus 0.15 to the power 1. That will give me technically 0.870 for that 3 decimal place. Then how do I get the discount factor of year 2? So DF2 for year 2 is going to be the discount factor of year 1, which I got it to be 0.870 divided by 1.15. I think by now you should pick up this skill. How do you get that 1.15? It was the addition of 1 plus, it was addition of 1 plus 0.15. And if I divide it, what am I getting? I'm getting 0.756. So then I move on to the discount factor of year 3. So I got that 0.751, 0.756, sorry. Then I divide by 1.15. There's no need for you to come back, edit the n from 1 to 2 to 2 to 3, 3 to 4. It's a waste of time. Though you still get the same answer. But my friend, you are wasting your time. You know, the day of exam, we do not have much time to waste. We need to be very clinical, right? So 0.6658 presumably becomes what? The discount factor. So I'll slot them here, then I'm good to go. You realize that the discount factor, which is higher, will have a negative impact on cash flow. Here gives us 0.870. The next bit gives us a discount factor of 0.756. The next gives us a discount factor of 0.658. So what do? I multiply the cash flow by the discount factor, and I'll get what you call discounted cash flow. The cash flow by the discount factor will give you discounted cash flow, right? So what do? 300 times 0.87. What answer am I getting? 300 times 0.870. That gives me 261. The next bit, 450 times 0.756. That gives us basically 340.2. And the last bit, I have 580 times 0.658. So that gives us 381.64, right? So if I sum all up, what am I getting? So this is 340.2. The next bit is 261. So that gives me 98 in total. That gives me a total discounted cash flow of 982.84. 982.84. So you can see clearly that when the discount factor was just 10%, the same cash flows, right? We got the discounted cash flow. We got a discounted cash flow of 1,079.98. But what happened? When the discount factor increased to 15%, we now have a discounted cash flow of what? 982.84. So that is why we tend to say that there is a negative relationship, right? So there is a negative relationship between a discount factor, which a discount factor is also called the WACC. So the discount factor or the WACC, and let's just say MPV or even cash flows. So we tend to give it in a general form that the higher the discount factor or the WACC, the lower the MPV. Because the cash flows, the cash inflows turns out to be small. Whatever be the case, to make the MPV small, right? So if the WACC increases, MPV falls. And that was the technique that was applied in deriving the investment appraisal technique called internal rate of return. So you see a student using one discount factor to get one MPV. Then he will say to himself that he wants the next MPV to be negative. And if you want the next MPV to be negative, then what do you have to do? You have to increase the discount factor. If you increase the discount factor, you get the NPV to be negative. So you can see clearly that an increase in the discount factor or the WACC will cause a fall in the NPV of the project. And we tend to say that there's a negative relationship between a discount factor or WACC and NPV. Right. This is not what we are to look at for today. Our meeting today is looking at how to compute KD, using internal rate of return, using the internal rate of return or technique. How do you compute KD using the internal rate of return? Right. So I'll start by is picking up a question so that at least we use it to ensure that we are okay. So we have fire coal. Fire coal. I'm just bringing up this question so at least we can move. Fire coal has outstanding Ghana cedi 660,000 of 8% bonds, on which the interest is payable annually on 31st December. The debt is due for redemption. The debt is ready for redemption at par on first January 2016. Let's put it that way, 2016. The market price of the bonds at 28th December 2012 was Ghana cedi 95. Effective tax rates is paid each 31st December. Calculate the after tax cost of debt. Here we are expecting you to compute the after tax cost of debt. How do we go through getting this question done? So move on to say solution. So the examiner wants you to calculate the KD in the formula of work, which we know the formula of work is equal to work equals KE. This should be on your fingertips by now. KE VE divided times VE, or divided by VE plus VD, that's the value of equity plus the value of debt, plus KD. Then because of Modigliani and Miller propositions, 1 minus T, whatever we tend to pay on debt is tax deductible. So say value of debt divided by the value of equity. So divided by value of equity plus the value of debt. So this is a way of calculating the WACC. And so far we are in good shape with all these parameters, with the exception of the KD. And that's why we are meeting today. But this KD here is the normal KD. But when you apply 1 minus T, then this becomes a KD after taking into consideration tax. So if we say before tax cost of debt, that means that we are not taking the 1 minus T out of it. We can tell you before tax KD, or we can say after tax KD, right? So we need to be particular about it. If it is after tax cost of debt, then that means that cost of debt, we have already taken tax out. That means it was KD 1 minus T. Right? So you need to be very mindful. If the examiner say the cost of debt is after tax, that means that he tends to have the cost of debt and has already taken the tax out. So the total value, if it is 10%, you will place this KD 1 minus T by the entirely 10%. Right? But this is not the case here. The examiner is teasing your mind in computing for yourself the cost of debt. Right? So how do you go through using the internal rate of return perspective? We can compute using the internal rate of return perspective by looking at it from the point of, first of all, say year here. Then move on. The next bit become the item. Some people tend to put over their cash flow. It doesn't matter, right? Then item over here. Then this time around, we come to the proper cash flow. Then we have the first discount factor. Please, you need to be very particular because this will look a little bit complicated. So you have discount factor times the cash flow give a present value. But over here, I'll not make it a present value. I'll say discounted cash flow. Then I'll predict another discount factor. And I'll get another what? Discounted cash flow. Right. So we start, please, you have to pick up the scale. We start with year 0. And the item over here should be the market value. Because if any item is in year 0, it is in a current state. And any value in the current terms is already in the present value. And a present value will be the existing market value. So the existing price of the debt is staged at what? 95 Ghana cedi, right? So we can take that statement from here. The market price of the bonds at 28 December 2012 was 95. So if the current market price is 95, I do not have any problem. I just slot here my 95 and I'm good to go. But because it is the market value, you will make this side what? Negative by putting it in brackets. So I can assume, let's say, a 5% discount factor here. And so you have to compute that. So just like internal rate of return, we look at a smaller percentage as a WACC and a higher. So if I've used here to be 5%, I can pick here to be 10%. Right? So at least I'll get one of it to be negative, one of it to be positive. Right. So let's proceed. So the discount factor of 5% in year 0 all the times happens to be 1. So the discount factor of any percentage in year 0 is 1.00. So over here, that of the 10% will also be 1.00. 3 decimal places, right? So over here, 1 times 1, this 1 here times 95 will give us a discounted cash flow here of 95. Then move on to the next bit. The same discount factor here by 1 for the 10% will also give us what? 95. Then we move on to the next bit where we are going to look at computing the interest. And if you look at it carefully, we indicated that Fireco has outstanding 660,000, right? 660,000 of 8% bonds on which the interest is payable annually until the 1st December. The debt is due for redemption at par on 1st January 2016. Let me just edit that a little bit. 1st January 2016. The market price of the bonds at 28 December 2012 was 95. So what are we looking at it? We are looking at it from the point of 2013, 2014, 2015, and at the end of what? 2016. So that is going to be how many years? In effect, we are supposed to consider it as what? A 4-year perspective. But what is happening? We are only looking at it as at 1st January 2016, because as at 2016 January, we are going to pay back the principal. So it will not start from January 2016 and end at December, because we actually paid the entire loan or debt as at 1st January 2016. So it will not get to the end of what? 2016. That is December, because we mostly pay interest at 31st December. And here lies the case, 1st January 2016, you finish paying for the loan. So that of 2012 will not be captured. We start from 2013. That is a full 1 year. Then we come to 2014, also a full 1 year. 2015, full 1 year from January to December. But when we came to 2016, January 2016, that same year, instead of waiting to December 2016 to pay the interest, January 2016, the beginning of the year, the first month of 2016, we fully paid for the loan. If I fully paid for the loan, will you wait to December and pay any interest? You have paid for the loan. So why do you have to wait and just move from January 2016 to December 12 months and pay an interest on an unexisting debt? So we have just 3 years over here. And 3 years with the nature of bonds, if it's 3 years, you are going to pay interest for the entire 3 years. And on the 3rd year, you are going to pay for the principal. Right? So from year 1 to year 3, we are going to calculate the interest which comes with it. So I have interest over here. And the interest over here, the interest rate was 8%, the coupon. The coupon rate was 8%. But all the time we say 1 minus T. And here the tax was 30%, so 0.30. What answer are we getting? So in effect, it's 8 times 8 times, what is a moment, what is 1 minus 0.30? That gives us 0.7. So this gives us 0.70. 1 minus 0.30 gives us what? 0.7. So if I pick up this 1 minus 0.30, that gives me 0.7. 1 minus 0.30, it gives me 0.7. Then I'll use that to multiply the 8. And then what do I get? I'll get 5.6. So I just slot over here. So instead of paying the 8% as interest on that debt, this time you are paying only 5.6 instead of the 8. Then what is the discount factor? Here you need to be very mindful. We are going to rather use annuity factor over here because the interests are compounded for 3 years, year 1 to year 3. So we will not use a discount factor. Instead, we use what? Annuity factor. So we are looking at the annuity factor of this 5% here for entire 3 years. When we went through bit in the case of the time value of money bit, I said that annuity factor can be computed as what? 1 minus into brackets 1 plus r to the power minus what? N, all over r. This was the formula that I gave you, and do not forget it, right? Very, very useful. So this is how to calculate annuity factor. So over here, calculate annuity factor 5% for 3 years will be 1 minus into bracket. I just slot in my bracket over here. 1 plus 5% is 0.05, right? To the power minus 1. Then what do? I divide by the r. And the r here is still what? That's 5%. That is 0.05. So what answer am I getting? I'll end up getting, if I compute it, I'll end up getting 2.723. Then what about the discount factor of 10%? So the annuity factor of 10%. So the annuity factor of 10% now becomes 1 minus into brackets 1 plus 0.10, because 10% is 0.10 to the power what? To the power minus what? 3. Because here we are looking at it for entire 3 years. So over here too, we make it to the power 3 because the number of years happens to be 3 years. So make the n 3, right? Good. So I will have divided by 0.10. So whatever answer I'll get, so you can compute that to assist. They make a move. So over here we have this to the power minus 3 over 0.05. Then on the other side, what do we have? On the other side, we have 1 minus 1 plus 0.10 to the power minus 3, all divided by 0.10, all divided by 0.10, right? So the annuity factor, sorry, for 10% for 3 years will now give us, let me just slot the figure over here, will now give us 2.487. So now I'll multiply the cash flow by the annuity factor. Under 5%, the cash flow was 5.6. I'll multiply that 5.6 here by 2.723. And what answer am I getting? Let me just use my calculator over here and see how best I'll get that. 5.6 times